Let's have a look at how much it costs to run electrical appliances. We're going to start off by making a fish finger sandwich. If you look at the air fryer, you'll see its rating plate. It'll give you its power, its voltage, its frequency. We don't already need to know the frequency. Working out the cost of an appliance, we need to know how much energy is put into cooking those fish fingers. So we need to know the power and how long that power's been on for. So the amount of power is measured in kilowatts. The amount of time in use is measured in hours. Because your electricity bill is charged per kilowatt hour, you generally get charged a set amount per kilowatt hour. You'll find that number on your electricity bill. Some people might have a variable tariff such as E7, E10 or time of use. At the moment, most people are paying around about 34p per kilowatt hour. But what is a kilowatt hour? A kilowatt hour is a measure of how much energy is used in 1 hour. 1 kilowatt hour would be 1000 watts of power used over 1 hour. If you look at the rating plate from the air fryer, the power is 1400 watts. Now the first thing we need to do is convert that into kilowatts, which is simple. We just divide it by 1000. 1400 divided by 1000 is 1.4 kilowatts. And then we need to times that 1.4 kilowatts by how long we've been using it for. If we used it for 1 hour, that would be 1.4 kilowatts times 1, which would be 1.4 kilowatt hours. So if we use 1.4 kilowatts for 2 hours, we'd times 1.4 by 2, and we'd have 2.8 kilowatt hours. Air fryers are often on just for a short period of time, might be on for 15 minutes. But we don't want the time value in minutes, it has to be in hours. So we would need to convert the 15 minutes into an hour. That's simple maths. You divide 15 by 60 and that'll give you 0.25 of an hour. And then we can times 1.4 by 0.25 and that'll give us 0.35 kilowatt hours. Now we've got our kilowatt hour, we just simply times the price we're charged per kilowatt hour by that number. So 34p times 0.35 will cost you 11.9 pence to run. So this air fryer, being powered for 15 minutes, would cost you 11.9 pence. We'll do another example in a minute. Sometimes your rating plate might not be able to read it, or it's missing, or it might give you different information. It might not give you power, it might give you amps, but you can still work everything out. And if something's missing, you can use your Ohm's law triangle or the power triangle to work out the missing numbers. If you want to know amps worth, the power triangle, you divide the power by the voltage, it'll give you the current. Or you might want to know what the resistance is. You divide the voltage by the current, that'll give you the resistance. Sometimes you might not have a rating plate, you're not sure. Say like a immersion heater, for example. It's quite a useful thing. If you know the resistance of an element and you know the voltage, you can work out the amps. And once you've got the amps, you can work out the power. You can, of course, get energy meters that'll give you the constant update of what power is being used. Or clamp meters are quite useful. You can take a couple of readings off the meter tails, want to get your background usage so you know what's being used, and then you can switch something on like an oven and you can measure the current that the oven's using by the increase on the clamp meter. Let's work out the cost of my fish fingers. So we know the power, 1.4 kilowatts, and I reckon it'll take about 12 minutes to cook them. 12 divided by 60 is 0.2, so we times the power by the time and get our kilowatt hour rating, 0.28. We times 0.28 by 34, that's 34 pence, our charge per kilowatt hour, and it turns out that it costs 9.52 pence to cook me fish fingers, depending on how well done you like them, of course. But that's not quite the end of the story. But this air fryer is not on constantly for 12 minutes. It's got a thermostat, and when it gets the temperature, it cuts out. The amount of current an appliance uses will constantly be changing, especially if you have a heating element that gets the temperature and cuts out, then switches back on again. So when you first switch on your air fryer, it'll bring itself up to temperature, and when it reaches the temperature, that current will drop down. Heating elements cycle between on and off to maintain the temperature you set it at, and also to prevent overheating. So we need to factor in this drop in current use when we're working out how much something costs to run. This cycling of loads is evident in some of the fixed appliances in your house, some of the fixed wiring. With the oven and hob, you can apply diversity to that because you have these various elements switching on and off, and because of that, the cable supplying the appliance can have a low cross-sectional area. But some appliances, even though they are thermostatically controlled, you're not allowed to apply diversity to, such as showers and instantaneous water heaters. You can see that an 11 kilowatt cooker could be on a 6mm cable, where a 10 kilowatt shower would have to be on a 10mm cable, and that's because of this diversity. So I plugged the air fryer into an energy monitor, it ran it through its cycle, and for some periods it was pulling, more than 1400 watts. It was pulling, sometimes it was 1500 watts, and then sometimes it dropped down to around about 36 watts. So the element had cut out, but the fan was still running, circulating the hot air. And so over the 12-minute period, I reckon it wasn't heating for about 4 minutes. And here's the sums for it. Thing is, if you're calculating 4 minutes at 36 watts, the actual amount is tiny. But with a bit of dodgy maths, I worked out probably cost just over 6p to cook me fish fingers. This isn't no super science. It really isn't. But it gives you an indication. This might not sound like a lot, but over the year, it can start to add up. I got some examples later on in the video where you can make massive savings. It's good to know which appliances are using a lot of current, because nowadays it can cost an awful lot of money. And with the new energy labels, a lot of this work has been done for us. Trying to work out what 10 minutes of power usage is not very practical because the numbers are tiny. So what they started doing, they use a larger time frame, so they'll use maybe 100 cycles and they'll give you the kilowatt hour rating for that. So you get a broader picture so you know what's happening over the months and year. So this is the energy label for a washing machine and the technical specifications from the manual. And as you can see, it's 48 kilowatt hours for 100 washes, which works out at 0.48 kilowatt hours per cycle. As the units are already in kilowatt hours, all we need to do is times that by our tariff, which is 34p, and it works out at about 16.3p per wash on that particular eco cycle. I think these energy labels are a little bit of smoke and mirrors. This energy rating is for a particular cycle. To me, the figures don't add up. If you look at the technical specification for this eco wash, it's telling me the energy consumption is 0.94 kilowatt hours. I can't see this 0.48 kilowatt hours in any of the cycles. So they say the eco wash is the cheapest wash, but it might not be the most practical because it's on for nearly 4 hours. And you can see the various different kilowatt hour cycle rates. The most expensive seems to be cottons at 60, that's 2 kilowatt hours. And you can see here it starts to add up over the year, between £40 and £80 a year. The cottons, that's nearly £180 a year. Obviously, it depends how much you use your washing machine. They changed the energy labels recently for dishwashers, washers and washer dryers, fridges and freezers, lighting and electronic displays, include televisions. But this particular fridge freezer I was looking at had an energy rating of A++. They got rid of all the A++. People were getting confused what it meant. Is A plus and A++ and A+++? Is there that much difference between them? The top, the green, is that's the best rating, down at the bottom rating G. And as you can see, this fridge freezer here had an A++ rating, but since it's been rescaled, it's down to an E. Doesn't necessarily mean it's not as energy efficient. They're not really giving out any Class A's at the moment. They're leaving those empty because they want companies to develop green equipment, and so they're reserving that. This fridge freezer, I reckon, will use 244 kilowatt hours per annum. So there's another 80 odd quid on your electric bill. But everything's so much more efficient than it used to be. And one of the biggest cost saving exercises you can do is convert your old halogen light to LED. Production of halogen lights is stopping. LEDs are so much more efficient. You can see the numbers here. A 50 watt GU10, and people tend to have a lot of these in the house when they're installed. I did some quick sums here. 50 watt halogen on for 5 hours a day. Each halogen could cost you £32 a year. You brought that down to an LED, 5 watt LED, you'd be paying just over £3 per bulb a year. So as you can see, the savings are massive. But the energy labels, again, they can be a little bit tricky to understand. I've got two here. They're both rated at 4 kilowatt hours per 1,000 hours. So for every 1,000 hours, it uses 4 kilowatt hours of power. But one's A rated and one's F rated. The reason being is, as I mentioned, they rescale the labels. In lighting, they're rated now on lumens per watt. Now a lumen is basically how much light you see from the light, how much light it gives out. The more lumens per watt you get, the brighter the bulb is for the given power, the better energy rating it will be. All LED bulbs will be a lot more energy efficient than the old halogen versions, but some LED bulbs are better than others, so watch out for that lumens per watt. Well, I hope this video has some use for you when it comes to calculating what things cost around the house to run. And as always, thanks very much for watching.